Hi there, this is Dr. John, your physics and math professor. Today I'm going to help you to find some easy ways to discover the sine, cosine, and tangent for 30, 45, and 60 degrees. Hopefully these tips will make it much easier for be able to get these on your own. Plus, there's another video called the unit circle, which you're going to be able to memorize those values extremely quickly. I'll start off with a really quick review of what sine and cosine and tangent are. You probably already know that, but maybe it'll just help to just check it out really quickly. So here's an angle with an opposite side, an adjacent side, and a hypotenuse. This is a right angle triangle, and we define the sine of this angle as being the opposite over the hypotenuse. I'm just going to write those like this, O over H, opposite to this angle, and the cosine of this to be the adjacent over the hypotenuse. Now, of course, there's two adjacent sides, but the longer side, the one that's opposite the 90 degrees, is always called the hypotenuse. So this one we call the adjacent over the hypotenuse, and then the tangent is the opposite over the adjacent. Opposite over the adjacent, or some people just remember it as being the sine over the cosine. I'm just going to write that in here really tiny, sine over the cosine. You can do this either way. So we're going to try to calculate the sine, cosine, and tangent for 30, 45, and 60 degrees. It's not like those are magical angles. It's just those were used a lot by the Greeks. They like to work with triangles, especially right angle triangles. And those were things that are easy to develop from triangles. And we're going to use those a lot in our studies. So I want to give you a really quick way. I've put two triangles out here for you. One is an equilateral triangle. That just simply means all the sides are the same. Sometimes people will put little sticks like that to indicate they're the same, and all the angles are the same as well. It's just forced to be that way. If the sides are the same, there's no way you can draw that triangle without having the angles the same as well. They all have to be 60 degrees. Remember, all the inside angles add up to 180. And then here's another triangle. This is called the 45, 45, 90 triangle. This is a triangle with one of the sides or one of the angles being 90 degrees and the other two being exactly identical, which what that does, it forces these two sides to be the same length as well. So this side is the same as that length. That side is obviously longer. The longer side is always opposite the hypotenuse. So I'm going to use these two triangles to find sine, cosine, and then tangent as well for 30, 45, and 60. Let's start with this one over here, and I'm going to give the sides various lengths. I'm going to call each side having a length of 2. Now you could use any length you want to. It's just calling each side a length of 2 makes this very easy. And then I'm going to draw a line down the center here. So I'm just going to erase that little angle there so I don't have too many things at one place. And draw a straight line here, which cuts this in half and makes this into a 90-degree angle as well. So that would mean each of these pieces here would have a length 1. So I'll just write that in there. So this would be length 1, and this would be length 1. And this side here is length 2. So now notice we have a right angle triangle on this side here. Let me just sketch that in here for you. This side here, right angle triangle, one side here is 1, the hypotenuse is 1. So how do we find the length of this side here? Well, that's very simple. I'm just going to call this value x here. So this would be this side here, use Pythagoras' theorem, 1 squared plus this length, x squared, is equal to this length squared, 2 squared. So that's 1 plus x squared is equal to 4. I'll just write those in there. 1 plus x squared equals 4. Subtract a 1 from both sides, and we're going to have x squared is equal to 3. Now, taking the square root of both sides means x is equal to plus or minus the square root of 3. Now, of course, since we're dealing here with something physical, like the length of the side, you can't have the negative. So we're going to erase that. We don't worry about the sign. It's going to be positive. So this length over here, this value, is going to be root 3. So now we're going to use this value of 1 here and 2 and root 3. I actually don't need this here. I don't need this. And just for confusion, I'm going to erase this side of the triangle since we probably don't need it. It might just be in our way so that our eye gets distracted there. So now we have a triangle up here. We have a 30-degree angle, and here we have a 60-degree angle. So let's look at the sine, cosine, and tangents of those. We're going to start off with the sine of 30 degrees. Sine of 30 degrees, take this one here, the opposite over the hypotenuse. That's going to be equal to 1/2. So I'm going to write that in here. The sine of 30 degrees is 1/2. And then I can find the sine of 60 degrees. Sine of 60 degrees is going to be this one. It's root 3 divided by 2. I'll write that in here, 60 degrees, root 3 divided by 2. And then I'll do the cosine in the similar way. So the cosine here of 30 degrees, this one over here, remember it's going to be the adjacent, not the hypotenuse, the adjacent, root 3 over 2. So the cosine of that is root 3 over 2. There you go. And then the cosine of 60 degrees. So we're down here, and we're going to be doing the adjacent, which is this one, over the hypotenuse, which is 1/2. I can write those in here. Cosine of 60 degrees is 1/2. Now notice these two are switched from each other. Root 3 over 2 and 1/2. And now we want to just look at the tangent. We could just simply take the sine and divide by the cosine, or we can look back over here. The tangent of 30 is going to be this one here. It's going to be the opposite over the adjacent. So that's 1 over root 3. And then the other one is going to be 60 degrees. It's going to be the opposite, root 3 over this. Root 3, like that. Now this one has a root 3 in the denominator. We don't like that. We like to always have roots in the numerator. It's just more beautiful. So what we do is we multiply the top and the bottom by root 3 like this. Root 3, root 3. And that's going to give us a root 3 over 3 here. And this one is just a root 3. So those are the two answers we're looking for the tangent. And I'm going to write those in here as well. The tangent of 30, root 3 over 2, root 3 over 3. And this one is just root 3. I don't know if you can see that or not, but those are flips of each other. They're the upside down of each other. We can see that easier here. All right, we've done 30 and 60. Let's quickly do the 45 as well. So now we're going to do the 45s, the different sine, cosine, and tangents for 45. I'm going to use this triangle. I've erased that over there because I don't need it. I'm going to call this side having a length of 1 and this side having a length of 1. They have to have the same length. And now let's figure out this length over here. Well, from Pythagoras' theorem again, it's this squared plus this squared. So 1 squared plus 1 squared is 2. So 2 is equal to, call this x, is equal to x squared, which means x has to be a root of 2. Just like before, it can't be a negative value. So this is going to be a root of 2 here. So now let's look at the sine, cosine, and tangent. I've written those things out here for you. Fairly easy to do. We can take either one of these angles. So the sine is going to be the opposite over the hypotenuse. That's 1 over root 2. 1 over root 2. And the cosine is going to be the adjacent over the hypotenuse. That's also 1 over root 2. And the tangent of this is going to be the opposite over the adjacent. So that's going to be 1. Or sine over the cosine. These are identical. So that's just going to be 1. Now, of course, just like I said before, we don't like having 1 over root 2 in the denominator like that. We multiply the bottom by root 2 and the top by root 2, and we're left with root 2 over 2. This is the common or more beautiful way to write that. So I'm just going to rewrite these that way. So this is root 2 over 2. This is root 2 over 2. And this is still 1. So let's write those in here over here. The sine value, I said, was root 2 over 2. The cosine value was also root 2 over 2. And the tangent value was 1. There you go. I hope you like and subscribe this video, and also check out my website where I've got this developed for you in a free download. I've also got a super easy way to memorize this chart, so you don't have to go. Your teacher may say, memorize this chart. I've got a super easy way. It's so easy, it's almost like cheating. Check that out on my website or on my YouTube channel as well. You can find that. So I hope that helps. If it does, I will hopefully see you in the next video, and take care. Bye-bye.